So, like congruent triangle, there are 4 tests. So let's recap what the 4 tests are. The congruent triangle, there's the SSS, SAS, AAS, and RHS. It's very similar to the congruent test. So let's explore these. Okay, so there are 4 tests in similar triangle. So for similar triangles, the matching angles must be equal. However, because they are different sizes, the matching sides are in proportion. They're in the same ratio. Okay, so look at these 2 similar triangles. Obviously, one is bigger than the other one. So 2 triangles are equal to 2 angles of a triangle are equal to 2 angles of another triangle. Then we say the 2 triangles are similar. Why do we need only 2? Because if I know 2 angles are the same, the third one must be the same by angle sum of triangle. So if you can prove 2 pairs of angles equal, we say the triangles are similar. So that's one test. The short way to do that is to write equiangular. So in a test, you write equiangular to indicate all angles are equal. Just remember this word, equiangular. Yeah, equal angle, so it becomes equiangular. Okay. All right, that's done. How about the next one? Yes, so all sides are in proportion. So all 3 sides are in proportion. All 3 sides are in proportion. So as you can see, everything has been doubled. Because that's times 2, that's times 2, etc. Right? So this one is similar to the test incongruence, SSS. So it's similar to this one, SSS. Whereas this one, equiangular, is similar to AAS, except we just have 2 A's. Right? It's similar to the congruent test. Okay, next one. We have 2 sides in proportion. So they all double, the 2 sides. And the included angle must be equal. That's called the included angle. So it's similar to SAS, except the sides are in proportion, 2 sides in proportion, and the angles are equal. It has to be the angle in between the 2 given sides. And the last one, similar to RHS, you have the 2 hypotenuse in proportion, the sides are in proportion, they are both right angle. So they all got triple, right? Triple. And they both has to be right angle, has to involve the hypotenuse. So these are the 4 tests. It's not very hard to remember them. Which one that used the most? These 2. Equiangular. That's used a lot in the exam. So make sure you know how to do that. Okay. There's a symbol for similarity. I should see. Okay, good. All right, sit down. The symbol for similarity is this. Triple vertical lines. That means similar to. Whereas congruence, it's triple horizontal line. So there's a difference between similar to, congruent, So not to get confused between them. How do I remember? See, congruent is like triple equal, right? Whereas similar to, just remember it's like triple parallel sides, right? When you do parallel sides, you do double lines. Triple parallel. So think about similar is triple parallel, congruent is triple equal. Okay, let's move on. Let's do some question. So today we'll do 3 pages all together. There's this page where we'll look at which test to use. The last page we'll do some calculation questions. Let's start with the first question. Choose the similarity test that proves that these 2 triangles are similar. Okay, so for the first one, which test should we use to indicate they are similar? Which test? The equiangular, because all 3 angles are equal, right? In fact, only 2's are required. So you say the triangle are similar. triangles are similar because equiangular. Okay, the key word is equiangular. Okay, good. Next one. Which test should we use? Test 4. So you have to write the full word. You say, can you see they're both triple? That's triple, right? But because it involves the hypotenuse, you say the hypotenuse. Now, unlike congruence, you can use abbreviation like SAS, RHS. In similarity, you're not allowed to use that. You have to write the full sentence. So you say the hypotenuse and one shorter side are in proportion. So the key word is are in proportion. Okay, keyword. The hypotenuse and one shorter sides are in proportion of the right angle triangle. Shorter sides are in proportion. How do I write it? Let me just double check. The hypotenuse and second side of a right angle triangle are proportional to the hypotenuse. Okay, so actually I need to add a new word. Sorry about that. Okay, so the hypotenuse and shorter side of right angle triangle. So you have to mention the word right angled triangle are in proportion. Okay, good. So hypotenuse and one shorter side of a right angled triangle are in proportion. That's me. Let's continue. Thank you. All right, let's move on. Next question. Next one is this one. Which test should we use? Test 2. So we say, again, we'll look at the wording. Two sides of a triangle are in proportion to two sides of another triangle, and the included angles are equal. So you say, two sides of the triangle are in proportion, and the included angles, you have to use the word included, angles are equal. So you have to give a description for similar tests rather than abbreviation. It's important you know how to do that because that's what you do in the HSC as well and in your exam. So two sides are in proportion and the included angles are equal. And then we've got one more test. Okay, the last one's quick to write. All three sides are in proportion. You just say all three sides are in proportion. Okay, all three sides are in proportion. All right, once we do this, we're going to go to the next page, which is the last page we're going to do today. We're going to do a question, an example, how to find a missing side, and then we're going to look at some other questions about similar shapes. Okay, all right, example 2. Let's look at example 2. So the two triangles, explain why they are similar. So you have to use a similar test. So what you do is this. Let's look at this triangle. Now the two triangle is the big one and the smaller one, right? CBD and the other one CAE. Now, why are they similar? You have to use a test. So first you say, and this angle equal to this angle. Angle E, just like congruent test, you have to write 3 reasons. Angle EAC, ECA equal to angle DCB. Why are they equal? Why is these 2 angles equal? No? Well, we have to explain why they're similar, not because we know they're similar. No? Common angle. Yes, they overlap each other, right? They overlap. So you say common angle, just like we have common sides in congruent triangle. So in this case, you say common angle. Common angles. Okay, so what's the next angle you know that are equal? Well, they are parallel sides, right? So what do we know about these 2 angles? Yes, Luca. EAB equal to DBC. Yep, what's the reason? Excellent. Very good answer. So you say, okay, just say EAC, same thing. Okay, let's say EAC is better. Angle EAC, because you look at the angle in that particular triangle, equal to angle DBC, corresponding angles in similar, corresponding angles on parallel lines. Now, remember, you only need 2 angles. That's enough. You don't need the 3rd one on parallel lines. Then you say, therefore, triangle EAC is similar to, note the symbol, just for equiangular. Because angles, you just need 2. Whereas all the other 3, you need 3 reasons. Because it involves 3 things you have to prove they are equal. So the one before, the only 2 angles. This one you need proportional sides, 2 pairs of proportional sides, right angle. This one here, 3 pairs of proportional sides. This one, 2 pairs of proportional sides, and the included angles are equal. So for only the first one, you only need 2 reasons. Okay? Alright, so you say similar to triangle DBC, reason equiangular. That's the structure of a similarity test structure. So I give 2 reasons, because you only need 2 angles being equal, and then write a conclusion. Therefore, the triangle are similar, equiangular. Done. Okay, now we're going to find the missing value of x. Now, we're going to take a different approach. Instead of finding a scale factor, you don't need to do that. Let's do it differently, and that's much quicker, and it's more likely you get the right answer. Let's label the side length. This is x, this is 5, this is 2, this is 3, right? You do not need to calculate the scale factor. All you have to do is to do the following. You start with the missing side x. Now, which side match with x? 5. So you write x over 5 equal. Pick another 2 sides, 3. Notice that I put the x and 3 on the numerator. So if you start with x on the numerator, you must put 3 of the first triangle on the numerator. So you get an equation. And once you get the equation, how do we solve it? You multiply both sides by 5, then you can find x. So you get x equal 3 over 2 times 5. Why is it not easier? So you start x match with 5, 3 match with 2. Write this down, and then times both sides by 5 to get the answer. So you get, because you want to get rid of the 5 in the denominator. Yeah, you want to get x on its own. The 5 is the x. No, the 5 is the denominator. So therefore, I want to get rid of it.
Why does that work?
Because the ratio are equal. The ratio of these 2 sides is equal to the ratio of these 2 sides. They're similar. Which is by scale factor, which I think is a bit longer. Yes. Yeah, you can just, that's right. So 3 over 2 is 1.5 and times by 5, which is the same thing. So you don't have to do separate lines of working. So you have to give a reason, ratio of matching sides in similar triangle. Triangles. Okay. Because you want to get rid of the 5. It's like doing this. If I got x over 2 equal to 10, how do you find x? You just times by 2, right? X is 20. Because the ratio are equal. So the ratio, just think about this way. The ratio of x to 5 is same as the ratio of 3 to 2, right? It's a ratio, right? The ratio are equal. And when you write ratio, you can write ratio as a fraction. Ratio, right? Remember, similar triangle means the ratio of the matching sides are equal. The ratio between 3 and 2 is same as the ratio between x and 5. And get this equation. And then when you solve this equation, get rid of the 5 to find x. All right, good. Okay, let's move on. All right, any other question? I'm going to answer them now. Other ones. Okay, it's actually very easy that way. X over 5 is equal to 3 over 2. Okay, now over there. All right, next question is, are all squares similar? Yes. Squares are similar. Is equilateral triangle similar? Yes. Right, you can draw a bigger one. They all have the same angle, right? Same angle, and all sides are in proportion. How about circles? Yes. How about rectangles?
No.
Why not? Well, let me draw what you want. So you can draw one that's long, and you can draw one that looks like this, right? So you could have angles are equal, but the sides are may not in proportion. So you could have 2 and 4, but this is like, say, 5 and 8. Can you see they're not similar? So this is double, but that's not double. So that's why no. Whereas the square, all sides has to be the same. So you have no choice there. They have to be similar. Same for equilateral triangle, but not for rectangles. How about isosceles? No, because you could have something like this, but something like this, right? But equilateral, you have to be similar. So no for isosceles. So we see something about similar shapes, there has to be regular. So if you got any regular polygon, just like the square and the equilateral triangle, they are all similar, as long as they are regular. All regular polygons are similar. Okay, any question? Press the wrong button. Okay, good. So we're going to stop there. You're going to do exercise 17.